Hello everyone, welcome to another video. In this video, what we're going to focus on is factorizing using the highest common factor. There are a couple of steps that you need to bear in mind when dealing with factorizing using the highest common factor. Step one, you must always determine the highest common factor of the algebraic expressions. Note that the highest common factor is the first factor. And step two, determine the second factor by dividing each algebraic terms by the highest common factor and place the quotient in brackets. To further understand this, what we're going to do, we're going to look at some examples. So here we have two examples and we're asked to factorize each algebraic expression, right? So the first one is 10 times x to the third power times y to the second power plus 5 times x to the second power times y to the fifth power minus 15 times x to the third power times y. So the first thing that we need to do is to identify the highest common factor between all three terms. So note all three terms has what is called a coefficient, right? Which is the number that is used to multiply the variable. So we're going to observe 10, 5, and 15. What is the highest number that I can divide all three numbers without leaving a remainder? That would be 5, right? So we're going to write it here. Then the next thing that we're going to do, we're going to focus on the variables. So note that x is common to all three terms. So the next thing that we need to do is to focus on the powers. So the x term with the lowest power is the one that we want. So note that this is x to the third. This is x squared. So this one has the lowest power because this one is x to the third as well. So we're going to write x squared here. Then now we look at the y's. We notice that y is common to all three terms, and the one with the lowest power is this one out here, because y is the same thing as y to the first power. So we're going to write that here. So note that 5 times x squared times y would be the highest common factor of each of these algebraic terms. So what we're going to do to find the second term, we're going to use the highest common factor to divide each individual term, and the quotient that we get, we're going to put it inside of the bracket. So we're going to take 10 x to the third power and y to the second power. We're going to divide that by the highest common factor, which is 5x squared y. So note now, 5 can go into itself one time, and 5 can go into 10 two times. X squared into x squared, that's 1, and x squared into x to the third, that will give us x to the first power. Y into y, that's 1, and y into y squared, that would give us y to the first power. So the quotient here would be 2xy. So we're going to write it inside of the bracket. So it would be 2xy. Then we're going to put back our operation sign, which is plus. Then we're going to do the same thing for the second term, right? So the second term is 5x squared y to the fifth power. And we're going to divide that by 5x squared y, which is the HCF on the outside of the bracket here. So note that 5 into 5 will give us 1. X squared into x squared will give us 1. And y into y, that's 1. And y into y to the fifth will give us y to the fourth. So the quotient of this would be y raised to the fourth power. Then we're going to put back our subtraction sign. And then we're going to do the same thing for the last term here. which is going to be 15 x to the third power y. All of that is divided by the HCF, which is 5x squared y. So note that 5 can go into itself one time and 5 can go into 15, 3. Note that x squared can go into itself one time and x squared into x to the third power will just give us x to the first power or just x, right? And then y into y will give us 1. So the quotient here is a straight, so we'll place that inside of the bracket. And then you close the bracket. And that's it. That's how you obtain the factors. So note that when you factorize this expression, which is number 1, you end up with 2 factors. The first factor is 5x squared y, and the second factor is 2xy plus y to the fourth power minus 3x. All right, let's apply the same concept to number 2. So the first thing we know that each term has coefficient. So we're going to observe the coefficient. We have 4, we have 10, and we have 8. What is the highest number that can divide all 3 numbers without leaving a remainder? That would be 2. So write it here. Then we're going to look at the x term. We have x to the 5th, we have x to the 4th, we have x to the 3rd. It is common to all 3. We want the one with the lowest power. So it's going to be x raised to the 3rd power. All right. And then we'll observe the y's. And y is common to all 3, but we want the one with the lowest power. So we want this one out here because y by itself is raised to the first power. So 2x to the 3rd power times y would be the HCF of all 3 terms. How do we obtain the second factor? By using the HCF to divide each term. So it's going to be 4x to the 5th y to the 5th all over 2x to the 3rd and y. So 2 into 2, that will give us 1, and 2 into 4, that will give us 2. X to the 3rd into x to the 3rd, that will give us 1, and x to the 3rd into x to the 5th, that will just give us x squared. And y into y 1, and y into y to the 5th, that will give us y to the 4th. Remember, you're just subtracting the powers, all right? So here, as you can see, that the quotient of this term is just 2x squared y to the 4th. So we must write that in the bracket. So we're going to put it here, which is 2x to the squared times y to the 4th power. Put back our subtraction sign. Then we're going to do the same thing for this term. And we're going to take 10x to the 4th y to the 3rd. I'm going to divide that by the highest common factor, which is 2x to the 3rd and y. So here, 2 into 2, that will give us 1. 2 into 10, that will give us 5. X to the 3rd into itself give us 1. X to the 3rd into x to the 4th will just give us x, or x to the first power. And then y into y, that's 1, and y into y to the 3rd, that will just give us y squared. All right, so therefore, the quotient here is just 5 times x times y squared. Now we have our last term, so put back our minus first. And then we're going to do the same thing with the last term there, so it's going to be 8x to the 3rd and y all over 2 times x to the 3rd y. So note that 2 into 2, that's 1. 2 into this 8 will give us 4. X to the 3rd into x to the 3rd will give us 1. And y into y will give us 1. So what we're left back with is just 4. So we'll put the 4 here and close our bracket, and that's how you factorize these two terms, right? Now let's look at another set of examples. So for these, for example 3 and 4, they are fractions, right? So does the principle change? No, the principle does not change, right? It's the same concept. So we're going to look for the highest common factor. But first, we're going to look at the numerator first. So when we look at the numerator, we have a being common to all three terms. So the next step that we're going to do is look at the one that has the lowest power, and this one has the lowest power here. So we need that one. We're going to take that one out. And to take a square out. Then we look at the b term. B is common to all, but the one that has the lowest power would be this one here. So we're going to take out b. Then now we draw back our division bar. We're going to look at the denominators. So we have 9, 3, and 27. So what is the highest number that can divide all three numbers without leaving a remainder? That would be 3. And then we have p common to both, all three, sorry. So the one with the lowest power would just be p, so it would be 3p. So therefore, the HCF is a squared b all over 3p. Then now what we're going to do is to use this to divide each term up here to get the second factor in the bracket. But note, when you are dividing by a fraction, it's the same as multiplying by the inverse. So what we'll do here is to take the HCF, the inverse of the HCF, and multiply each term. So the first term would be a squared b all over 9p. And instead of dividing by this fraction, it's the same as multiplying by the inverse, which means that the denominator becomes the numerator. So it's going to be 3p all over a squared b. Now what this allows us to do is to just cancel easily. So note that we have a squared b in the denominator and we have a squared b in the numerator, so that divides itself one time. And here we have 3, so 3 into 3, that's 1, and 3 into this 9 will give us 3. And p into p, that's just 1. So what we left back with is 1 times 1 times 1, which is just 1 as the numerator, and 3 times 1, which is just 3. So the quotient of this is just, well, the product side in this case is just 1/3. So we're going to write 1/3 here. And then I'm going to put back our subtraction sign. I'm going to do the same thing for the second term. So we're going to write it here, which is a to the 3rd power, b to the 4th power, all over 3p squared, and multiplied by the inverse, which is just 3p all over a squared b, right? Then we can do a little bit of division. So note here that a squared into a squared, that's 1. And a squared into a to the 3rd, that will just give us a. Then b into b, that's 1. And b into b to the 4th, that will give us b to the 3rd power. So finish with that one. Then it's going to be 3 into 3, that's 1. 3 into this 3, that's 1. P into p, that will give us 1. And p into p squared, that will just give us p. So as you notice, 1 times anything will give you back that thing. So we have 1 here. So when we multiply up, our final answer would just be a times b to the 3rd all over p. So we write that inside our bracket as our second term here. So it would be a b to the 3rd all over p. To get the 3rd term, write back our operation. And then we're going to do the same thing. So it's going to be a to the fourth, b to the fifth, times c, all of that, over 27, p to the third, multiplied by the inverse of the highest common factor, which is 3p, all over a to the third, sorry, a squared b, right? So now we can cancel out some terms. So here we know that a squared into a squared is 1. A squared into a to the fourth will give us a squared. Then b into b, that's 1. Then b into b to the fifth will give us b to the fourth power. Then we don't have anything to divide this c, so we put it back up here. All right. Then now we're looking at the 3 over here. So 3 into 3, that's 1. 3 into 27 will give us 9. Then p into p, that's 1. And p into p to the third will give us p squared. So what we left back with as our answer would just be a squared b to the fourth c all over 9 p squared, and that will give us our third term. So write it here as a squared b to the fourth c all over 9 p squared. I will close our bracket, and that would give us that's how we factorize this term here. So now we're going to move to our last example here. Now, first thing that we need to determine is our highest common factor. So note that each term in the numerator has a coefficient, which is 9, 3, and 6. So the highest number that can divide all three would be 3. Then we're going to look at the variables. So we have L squared, we have L, and then L squared. So L is the one with the lowest power there. Then we have M, M to the second power, M to the second power. So M is the one with the lowest power there. So we finish with our numerator. Note that N is common to all three. The one with the lowest power is just N. That's our 8th there. And then we know that to get our term in the bracket, we must use the inverse of the LCM to multiply each term. So I'm just going to go in and put in my plus sign. All right. So now, first one would be 9 L squared M all over N multiplied by the inverse, which is just N all over 3LM. So note M into M, that's 1. Then M into this M will give us 1 also. L into L, that's 1. And L into L squared, that will give us L. And 3 into 3, that's 1. And then 3 into 9 will give us 3. So our answer is just 3L here. So first term that will go here is just 3L, right? To get the second term, it's the same idea. So we're going to put 3L M squared all over N squared multiplied by the inverse, which is just N all over 3LM. Then N into N, that's 1. N into N squared will give us N. Here now, 3 into 3, that's 1. 3 into this 3, that's 1, 2. L into L, that's 1. L into this L, that's 1. M into M, that's 1. And M into M squared, that will give us M. When we multiply, all we'll get here is just M over N as our solution. So write it here as M over N. And to get our last term, it's the same idea. So it's going to take the last term there, which is 6L squared M squared over N to the third power times the inverse of the highest common factor, which is just N all over 3LM. So M into M, that's 1. N into M, sorry, that's 1. And N into N to the third power, that's going to be N to the second power. Then 3 into 3, that's 1. 3 into 6, that will give us 2. Then L into L, that's 1. L into L squared, that will just give us L. And M into M, that's 1. And M into M squared, that will give us M. So our answer for this one is going to be 2LM all over N squared. And that's it. So all it takes is just a little more concentration because you're dealing with the powers. So you just need to focus a little bit more than usual. And it's the same procedure, right? Just remember that dividing by a fraction is the same as multiplying by the inverse of that fraction, right? So to ensure that you fully understand, there are 6 questions for you to complete. So please feel free to complete these 6 questions. All right.